Let's talk about Wi-Fi. What is it? Where does it come from? And what's going on with it these days? It seems that it's everywhere and it's being used for lots of applications. So let's go take a look. There's a number of different terms that you might hear. You might hear about wireless LAN. You might hear about 802.11. You might hear Wi-Fi. Are all of these synonymous? Or there's some differences between these terms? Firstly, let's take a look at what it is in the first place. Comparing with other wireless technologies, the range of communications that Wi-Fi supports can be considered to be mid-range. So it's not as short range as technologies like Bluetooth, for example, and those will be within a few meters, cable replacement type technologies. And then on the other hand, you have the longer range wireless like cellular, and that will be on the order of a few kilometers. Besides that, you can have even larger ranges like satellite communications, but we're here talking about terrestrial communications anyway, so mid-range. Considered as a mid-range wireless communication system, we also see the term WLAN or wireless local area network. So Wi-Fi can be thought of from the perspective of being something like the local area networks or LAN technologies that we knew of before Wi-Fi came on the scene. So, before Wi-Fi came on the scene, we are familiar with things like Ethernet. Those are making local area networks possible. Now, then, Wi-Fi can be thought of as a wireless version of local area network technologies. Wi-Fi is seen in all kinds of devices and all kinds of applications these days. We see Wi-Fi in digital camcorders, in computer peripherals, in digital still cameras, portable AV players, portable music players, game consoles, DVD players, DVRs, set-top boxes, TVs, music receivers, home theaters, mobile internet devices, cellular handsets, netbooks, laptops, and so on. So that was the application perspective. From the standards perspective, Wi-Fi is something that comes from IEEE, the Institute of Electrical and Electronics Engineers. What is 802? 802 is a set of standards for technologies about networks carrying variable size packets. Within this 802 family of standards, there are various things like, for example, Ethernet, token ring, and so on. Each of them will be like 802.3, 8 for Ethernet. And when it came around to Wi-Fi, it got the number 11. So 802.11 is the standards for Wi-Fi. It's interesting to note that these days 802.11 and wireless LAN and Wi-Fi are almost synonymous, but it doesn't have to be. So in fact, the term wireless LAN is something more general. Before IEEE standardized 802.11, there were a variety of proprietary solutions for wireless LANs. And these were not compatible with each other, didn't really take off because it was like different companies coming up with their own solutions. This is something that therefore took a standard to gather the momentum to actually explode and become what it is today. So we have Wi-Fi everywhere. All right, so that's kind of between wireless LAN and 802.11. So the third term here, Wi-Fi, where does that come in? Well, there is this thing called Wi-Fi Alliance, which is a global non-profit industry association. And this brings in the remaining piece of the puzzle, because you have the standards which allow vendors to manufacture devices that are compatible and work together because they follow the standard. You need one more piece of the puzzle, and that comes from this Wi-Fi Alliance, because with the test suites that they provide, make sure that the devices from various vendors conform to the standards and to certain specifications about certain subsets of the standards, certain features, and that's what really is the missing piece. It allows devices to be certified, and then they can work together. So you can go buy Wi-Fi adapters, access points, which can be made by different vendors, and you see this Wi-Fi certified logo on these devices. You can be assured that they will be compatible, at least up to certain degrees and supporting certain features. Just a quick market overview, because it's not really a course about markets, but Wi-Fi today is everywhere, so we see it in more devices than even LTE, which is talking about the cellular side. I mean, LTE is doing pretty well, and it's interesting to note that, for example, travelers really love Wi-Fi, so you need Wi-Fi to be provided free by a hotel. If not, people might not want to stay there. It could even be a deal breaker, and they will book elsewhere because it's so important for them. But besides travelers, most other people also like to use Wi-Fi. As we see in this chart, there is a capacity gap in terms of mobile data, because the demand for mobile data has been increasing and increasing, and it just keeps growing exponentially. And cellular cannot provide it for various reasons. So macro network capacity is limited, and there's this room here then where Wi-Fi has been filling a lot of the gap, and so that's what we see here. We continue on with our introduction of Wi-Fi. Let's talk a bit about the history of Wi-Fi. In 1985, a very important ruling was made by the FCC. The FCC is the Federal Communications Commission, and it's a very important organization in the US as far as communications is concerned, and in fact, it has influence over the whole world as well, because many other countries also observe carefully and follow some of these developments that happen in the US. So, for example, this important ruling in 1985 was that the FCC allowed the use of some experimental ISM radio bands. What does this mean? Industrial, scientific, and medical. But what's so special about these bands? Well, it's not about the locations of the bands themselves. So let's say like 2.4 gigahertz, 900 megahertz. It's not so much about the locations of these bands, but the way that these bands could be used, because these would be unlicensed. You see, one of the problems with deploying new wireless systems, or investigating and experimenting with new wireless technologies, is that usually the FCC would be requiring licenses so that you prevent various kinds of interference from happening. Now, sometimes when you want to experiment with things, it's not so convenient to be talking about licenses and stuff, because you're not sure exactly how your communications will be used, and you want to be able to adapt and do things. So having these unlicensed bands was a great way to enable innovation and trying new things. But it also was a foundation that allowed for Wi-Fi to emerge later on. Well, one thing about these unlicensed bands is that it's not completely chaotic. It's not like the FCC says, okay, within this band you can do anything. Okay, so there are still some rules for these unlicensed bands. The radio transmitters have to play nice. They have to follow certain rules. There's certain limits on the transmissions, but they don't have to go get a license from the FCC in order to be legally transmitting in these bands. So that's a big deal. Anyway, because of that, so wireless LAN systems started to emerge. There, as I mentioned before, various proprietary solutions were developed by private companies even before 802.11 emerged. They did not quite take off because they were not compatible with each other and didn't really get the kind of ecosystem, large, wide-scale ecosystem that you need for something like Wi-Fi for something like Wi-Fi to become ubiquitous like we see it today. Anyway, in 1990, then work began within IEEE 802 to specify some kind of solution for wireless local area network. By 1997, the first version of 802.11 was published. It got off to a bit of a slow start, as with many technologies. There were certain flaws and problems and so on. So a revision quickly came out in 1999. But also in 1999, another important thing that happened was the formation of the Wi-Fi Alliance. At that time, it was known as WECA. But as I mentioned before, with the Wi-Fi Alliance having this stamp of approval, it allows compatibility when different devices from different vendors can work together. So then you have Wi-Fi certified labels applied to these devices, and it's an important final piece of the puzzle. Besides the standardization itself, to have this other organization that can help to ensure that vendors' devices are working nicely with each other by following certain things according to the standards. So, as we see in this timeline, wireless LAN, WLAN came first, followed by 802.11. Finally, Wi-Fi, the name Wi-Fi through the Wi-Fi Alliance, that came last, and it was the final piece. And then we had everything that, together with the demand for mobile data, created this situation where things were just in place for this tremendous explosion and growth of Wi-Fi. So there was this exponential growth, with especially at this time also the increasing popularity of laptop computers. People soon realized that, wow, standardization really made a big difference. It allowed for this interoperability between systems and growth of this whole ecosystem of Wi-Fi devices, access points, and related products. In fact, within a couple of years, cellular operators started feeling threatened around 2000 2001, and cellular had been established for a couple of decades already. So you imagine the great success of Wi-Fi that allowed this development to occur. There were various basic enhancements that started to be added after Wi-Fi came out, and there's a certain process where IEEE will then introduce amendments. And so here's an example of some of these. 802.11i is an important one for our course today because it's about security. Physical layer amendments we will talk about in this course as well. And anyway, so there's a certain process where these amendments get introduced, and later some of them get rolled into the main base specification.